Hey everybody, I just wanted to take a minute to show you something that I've been working on. It's kind of an interesting problem, so I thought it might be interesting for some of you to see. So what I've been doing lately is I've been working on the visualizer and setting it up in Unity, which is a game engine. And one of the things that I've been trying to get right lately is gobos. And for those of you who don't know, what a gobo is it's a circular metal disc like these that has a pattern cut into it. And what you do is you shoot light through this, and the metal areas don't allow the light through, so just the cutout passes light through. And you get something like this, where you have the pattern projected onto whatever surface you're shooting at, and then if you're using haze, you get these nice beams of light happening here. So what I've been focusing on right now is these beams of light and how to make these happen. Because in the game engine that I'm using, and most game engines, they don't allow you to do volumetrics. And what volumetrics are is what you see happening in real life, where you're shooting a light source through a substance like haze, and the light is bouncing off of it. That is really complex to make happen, and it just doesn't work well through game engines because you're trying to process it all real time. So what I need to do in the end is have an image that wraps around a cone like this and creates what looks like that. And what I would like to have happen is it be fairly accurate to the gobo. So I'm going to go to Roscoe's website here, and Roscoe is a producer for lighting supplies. They manufacture all sorts of gobos, and I'm just gonna pick one of these here, and I'll talk through my approach to making this happen because I think it's kind of a cool way to go about it. So what I'm doing is for each gobo that I want to process, I'm going to run a line through the gobo. And on that line, I'm going to calculate how many pixels are black, how many pixels are white, and that'll give me the brightness if I was looking directly through the light cone at that point. And then I'm just going to move 1 degree and calculate again and again and again and again, 360 degrees around the circle. And with each one of those sections that I calculate, I'll have a brightness, and I can draw a line as if the light was being shot through there, and I get a somewhat decent representation of what this would actually look like if light were shooting through it. Now, there's some things that just aren't quite right with it, because this is a two-dimensional image that I'm creating, and it's simulating an actual three-dimensional object with depth to it. So there is that, and at this point, there's not a whole lot that I can do about it. I've got some ideas on how I can make it better, but I'll show you how it works right now. So I'm just going to go ahead and save this. I'll just save it as Gobo 3. And then I'm going to load this program. So this is the program that I created to be able to do this. And I'll load the image, and it's just going to run lines through here, and you see it generating real time here all of the lines within this image. So there we go. Now I have a two-dimensional image showing what this is going to look like roughly with the light passing through it. And this may not make a whole lot of sense as you look at it now. I'll explain it just a little bit here. This side of the image is what is like right up against the light source, and then it gets dimmer as it goes this direction as the distance from the light increases. So I'll go ahead and let me load the visualizer here. So right now there is no gobo on these, so it's just plain light shooting through there. So I'm going to go ahead and save this. I'm just going to save it over this image here, and then there we go. We have our beams of light. And let me go ahead and just move this around a little bit. And it looks pretty decent. It's not perfect because it is a two-dimensional image being mapped around this cone. But, you know, it's not bad at all. especially for how well the visualizer is going to run this. It's very processor friendly, and it works pretty well. So that's what I got, and I just thought it was worth showing you. So hope you guys like it, and thanks for watching.